Okay, you guys, so I'm going to put this in the XY coordinate system. Now, in doing that, whenever possible, use symmetry so that it works out nicely for you. Okay, so in this case, I know this is 6 and I know both sides are 5. So I'm going to put this triangle so that it's symmetric with respect to the y-axis. So this is going to be 3, 0, and then as you can see, the other sides are 5, and hopefully people can see that it goes down. The altitude is 4. It's the 3, 4, 5 right triangle. So I know that this point is 0, 4. So I am putting mine like this. If I wanted to, I could, and I can try another one. I could move it up and orient it so that it's at 0, 0. This side line is at 0, 0. But I'm choosing to do this. Okay, so we're talking about this plate, which is triangular. Okay, our next step is we are going to subdivide into n subintervals. And keep in mind, this, by the way, should have been 0, negative 4. It was 4 below, so this is negative 4. And now I'm going to put the typical rectangular slice. Now, we are going to use the formula for force. F sub I, the force exerted on this triangular plate, is density times the area of the typical rectangle times the distance below the surface. So in this problem, we're now going to do the area. So looking at this, the area of this rectangle is, now because of symmetry, this side length is, half of it is x sub I, so the whole length will be 2x sub I, and then of course the width, because I subdivided the y-axis, is delta y. So it's 2x sub I delta y. Okay, you guys, so now I'm going to have to replace the x sub I where x will be a function of y. So I need to get the equation of this line, because that's what's going to give me my x sub I. So now we have to use our techniques for getting equation of lines. So certainly this will fall into the y minus y1 is slope x minus x1. So I can do the slope either by using the ordered pairs, or I know by the up to over ratio that the slope here is up 4 over 3. So the slope is 4/3. And using either the 3, 0 or the 0 minus 4, let's use the 3, 0. I get y minus 0 is 4/3 x minus 3. So I get that the equation y equals 4/3 x, and then I distribute that through and I get negative 4. Okay, so now we're going to solve for x in terms of y, and we get 4/3 x is y plus 4. And then I get basically that x is 3/4 y plus 4. So I can now write the equation of that line as x equals 3/4 y plus 4. So now I'm going to replace x sub I with the expression for x equals. So now we can say a sub I is 2. The x sub I will be what we have in here. So it's 3/4 y sub I plus 4 times delta y. And now we're ready to use the formula to give us d as well as d sub I, and then we'll get f sub I. So now the next piece is we need d sub I. So d sub I is the distance below the surface. So that is this distance, d sub I. I don't know if people can see that there. Now, the fact that that is d sub I, who can tell me what that distance is? Remember, you have to think upper minus lower. So doing upper minus lower, it's 0 minus y sub I. That is d sub I. Okay guys, so now we get the force exerted on that typical rectangle, which is density, area of that typical rectangle, and distance from the surface. So F sub I is the density of water will be 62.5. The area on the of that typical rectangle is 2 3/4 y sub I plus 4 delta y. I'll put that out here. And the distance from the surface is 0 minus y sub I, which I can write as negative y sub I. Should put that there. So this is the force exerted on that typical rectangle. And now we're going to sum those all up as I goes from 1 to n, take the limit, and we now get the integral that represents the force exerted on that entire triangular plate. So it is integral 62.5 to 3/4. Instead of y sub I plus 4, I put y plus 4. Instead of negative y sub I put negative y. Delta y becomes dy. And now the only thing I need to do is go back to the triangular plate and see the limits of the plate, because you can't be anywhere else but on the plate. So now, you guys, we go back to the diagram, and the limits of integration are where the plate limits are. So the plate was from -4 to 0. Okay, so now we go back, and the limits are from -4 to 0. And this is the force exerted by the liquid on the plate.